Hey guys, welcome to episode 12. I decided I'm gonna go and try to fix that bug off camera because watching somebody fix bugs is probably as interesting as watching the paint dry. But I didn't commit anything, and I'm gonna walk you through slowly to what I've done, so that can also be recorded down, right? So the first thing I've done, I went to the place where everything was crashing and decided to unconstrain the types more. So what I mean by that, right here, as you can see, I commit immediately to a maybe type, which is okay, but I find it really helps to push the bug out by not constraining yourself to a type if you cannot do. And right here we really don't need to. So one instance that would solve the problem we have here is to use an alternative which resides in applicative package. An alternative is a lot like it's a lot like a monoid type class. However, the difference between monoid and alternative is, as you can see, alternative does take a type of the element that satisfies the monoid properties. And you see you have an empty here, which is the identity, and this is the associative combination operator. So that's what we're going to do here first. And then, because as you can see, alternative comes from applicative, you still have pure, and instead of nothing, we're going to use empty. So we have a secondary problem here. We test whether our accumulator is empty or not, and there's no such thing as inapplicative. However, this isn't. There's two ways we can solve this, right? The first way is to we have scoped type variables, right? So this A type right here is exactly the same as A type in this setup. So we could add an equality constraint, and we could replace is nothing with testing accumulator against the empty, which works. But if you look at this operator, the way it's implemented is that it's gonna take the first non-empty value and just to run with it. So if we do, for example, nothing combined with just 5, it's just 5. If you combine that later with just 10, still gonna be just 5, or combine with nothing. So the way to express this is that instead of testing against empty, we want to take accumulator and combine it with the element, with the pure element wrapped in a container. And then, of course, here we need to return accumulator, not empty. And that goes in here. Sorry. So if our probability value is higher than P, then try to combine the accumulator with a pure element, which is gonna keep the accumulator if it's a pure value, or take the pure element if it's not. Otherwise, just return the accumulator. And that's first. And we can probably do this. The second thing which we will do, we shall let me just see if this works first. Bon. It's still crashing, right? Great. So the second thing we need to do, we need to figure out what kind of values are we getting out. And the way to do that is to use debug trace. And now there's quite a bit of them, quite a bit of different tracing functions in here, as you can see. But the one we're going to be using is this one. What it does, it takes any showable value and passes it on, just like an ID function, but it has a hidden side effect that it's going to print it out to standard error output. As you can see, it doesn't wrap that side effect inside IO. So these are really purely debug functions and should not be used for any useful work. And what we're going to do right here, we're going to try to trace the list we're returning. And in order to do that, this is going to crash, as you can see, because we don't have a show context. So we're going to add that. And because we're calling to CDF here, it means that the show context has to exist here, and we can remove the equality because we're not using it. Right. And a great thing, we don't need to use this anymore. And here, empty. So I just want you to realize that from this moment on, we are not committing to any alternative type. We're just using whatever the function before decides. So the fact that we are extracting the alternative type using from just is going to specialize this to a maybe value, and it's going to specialize this to a maybe value. Which is good because, you know, if some point, if we, instead of from just, we want to use head, then all this code is going to work. And it makes it easier for us because if we're using maybe, well, first, as you can see, we were using maybe specifically functions. Is nothing is a pretty clear identifier, but ideally you would not use specific identifiers. You would use as common identifier as you can, because then there's a greater chance that whoever is reading your code, they're not going to have to look it up. Let me just clear out the white space at the end. Done. Okay. So actually, let's do it from here. I want to show you. So one problem here is that because the curses overtakes our screen, we can't see anything that's printed to standard error. So the way to do that, we're going to build and we're going to run it manually, but we're going to redirect all standard error into a file like this, right? And then if we print the error log, you can see that we get what we printed out here, which is our continuous density function. And from right here, like, I did spot an error, but I want to print it out nicely, just so that we can verify that the rest is working fine. So we want to find brace and comma, and we want to break that. This is an enter character, and I got it by pressing Ctrl V, which is for special characters, and then hitting enter. And I want to repeat this across whole line. Okay. The reason I'm doing this is because this cleanup is going to make it easier to get it up in LibreOffice, right? Let me just find a suitable screen where we can open it. Yeah, this is good. So I could actually just move it here. There you go. spreadsheet. Right, and then we can just select that, push it over here, and see, because of the format, it thinks it's a character separated values. We import, and that's nice. This, I don't find these values as easy to read, so I'm gonna change to that. And now, come on. As you can see, our values are that from 0 to 0.1, we're gonna get magenta flower, which is quite small, and that's exactly what we wanted, because where am I? Right, main, in our test distribution, you can see that magenta flower has the smallest part of the distribution, so this makes sense. The yellow flower has a range between 0.01 to 0.04, which is 0.03, and it makes sense because yellow flower is the next in line of rarity. Then we have red flower in a range from 0.04 to 0.09, which is 0.005. Also makes sense because red flower is a third, even if this list isn't sorted, but it's a third one in the list. Then we have blue flower with a range of 0.06. We have a rock, and then grass takes almost the full 50% of our whole continuous density function, and that all makes sense. So we know that distribution is set up all right, except it's reversed. But the reversal is not the bug here. The bug is here. The reason why is because when I assemble our continuous distribution function from our probability density function, the problem is that I assumed that our probabilities are going to be set up so that if you get a range that's if you want to get the last element, then you need to fall between the range of 0.76 to 1. So all of these would be moved upwards like this, right? And this would be here. So this would make, this is the code I wrote, but that's not how the distribution is set up. So what we're going to do here, we're just going to reverse this. And then we know that if probability is lower than P, let's say we get 0.03, we are in a range that's lower than yellow flower, so we have to be magenta flower. Pardon me, if we get probability lower than 0.01, then we are in a range between 0 and 0.01, so we have to get magenta flower. Everything above 0.01 is going to be the yellow flower. So these things are not the start on which it's not the lower bound of the function, it's the upper bound, and that's it. The second thing, which isn't a bug, it's just slightly annoying, is that I've been using fold, the left fold, but I'd like this to be in order, so we're just going to replace it with the right fold. Here it doesn't really matter, it just sums everything together. Right, so if we try this again, just a moment. Right, fold function also changes the order of parameters. Try again, and now, as you can see, work, and you can kind of gauge that blue flowers are most plentiful, followed by quite a bit of red flowers, which would be much more visible if I made them bold. There's yellow flowers and magenta flowers. The little stars are only visible here and there. So that's a bug fix, but I want to move on. So I don't like that we don't have any check here, because we know that this non-empty function, a non-empty list of a tuple of a float and element is a continuous distribution function simply because we named it so. And I don't like making up names when I can make up types. So we're gonna go here in our wrongly named module, and we're gonna create a new type, CDF of A, that carries pretty much the same thing as this, right? CDF and unwrap CDF. So whatever these new types are wrapping is the same value, but they're the same types. They're the different types now, which means that they can be checked by a compiler. And that's great, because it means that we won't make bugs where we by accident unwrap PDF and then pass it to a function to pick things. So the second thing we're going to do, we're going to move the creation function here, and we're going to rename it to from PDF. Because what we want to pass in a PDF and we want to get out a CDF. And right here, we're going to remove our unwraps, and we're going to expose from PDF. We're going to expose our smart constructors. And the last thing to observe from PDF. The last thing, do I have a buffer? Yeah, I have buffer number 5 that needs to go. 5 by, good. The last thing I want you to observe is that the picking an element from a distribution is not necessarily something that needs to be pushed out of the distribution handling code. So why don't we just move all of this here? We always pick elements from the CDF. So we want this to be called pick element. We want to export it. Find first is always only used here. Crashing. And of course we need monad random. The second thing, we don't have a visible PDF, so we have to pass it in. Pardon me. We don't want this. We want CDF, so that the conversion can be made elsewhere. Thank you. Good. And we're gonna need some of the things. We do have to keep this here because of the constraint though. Alternative can move here. From just can move here. Non-empty can move here. And we already have it, so we just need to move the sort by. We don't need to trace anything anymore. We don't need the fold L there. And this thing is now called pick element. And what we want, pick element requires CDF. So we're gonna, oh, and we can get rid of that. It's not necessary anymore. So we can use our view patterns to immediately convert our PDF to CDF, and we're gonna do from PDF and get CDF parameter pick element. This should, if I save, this should load. Okay. We need view patterns here, right? Okay. Trace, we don't need this anymore. We don't need show constraint. Ah, yes, we want to wrap this with a smart constructor. And 53. Right, and here we can unwrap CDF, which is all right because we are inside this module, so we can see the internals. Still works. Boom. Then, one thing which I'd like to do, I'm not sure that I don't like inventing these unwrap names, and what I'm gonna do, I'm gonna introduce a new module from Haskell called new type. I think it's new type, not new types. Let me verify. Yeah. Great. And what this module does, it basically just gives you a type class for new types. It's in import control new type, and as you can see, control new type, new type. It's a multi-parameter type class that has your new type and your output type. It creates a functional dependency between both, and then you get pack and unpack out that you don't even have to implement, because the way they work, they're defaultly implemented just as a course, which works perfectly fine. So what we want to do here, we're gonna introduce multi-param type classes, and I think we're gonna need flexible context, but I want control new type. And I just made this pretty sort. I should probably use the H ident, but that's for some other time. So here, instance new type of PDF of A to produce non-empty float of A. No need for a where clause, no need for implementations, because it's all the same. I wonder if with derive any class or something, we could do this even in a deriving clause. I'm not sure, but whatever. And let me just get rid of this, change this to that. There you go. And then the same here. CDF. There. And then where we had our manual unwrap, we're gonna call unpack instead. And here, unpack. Dish. Right, that's what I thought, because we just need flexible instances, right? Test. All good. That's that. What else did I want to do? Well, I actually think that that's everything. But since we still have, oh, pardon me, let's move it. Yeah, it's kind of quick to fix bugs when you do it beforehand, and just come here to show off how fast you Let's spend some extra time and modify all of our state monad looking functions to state monad functions. So we don't need this. The way I like writing this kind of code is that all the querying functions, so functions that don't change anything, just remain plain old pure functions. All the functions that do modifications, I'm gonna try to make them into state monad functions. I just think it's a bit easier to use them than just writing this. So let's start. We do have a state here already, so we're gonna use state. And state of character A, and then the value of anything. Right? So we pass in a value and we get a state function now. I think I explained in one previous video that every len operator you have has its MonadState version, where you just replace this with that and that's it. And actually, why don't I just do this? Character of A. And then the constraint is going to be named, and there we go. Here, same. I like ordering my constraints from simpler to more complex. Crash, of course. And this is going to require flexible contexts here. Let me just this isn't sorted either, is it? Make a note to add h ident for the next time. But yes, so these are all state functions. Yes, yes. This specific operator isn't, so we can remove it. So we don't return any value, probably not here either. 211 in main, yes. So here we modified avatar object, but right now, how do we do this? Right, we do exec state over it, and we flip it because we do want to do the execution first, and then pass the value that we want to execute over last, and then right here we can just ETA reduce it. Same here, flip exec state. Why not do that? I don't know if that's gonna work. Maybe it should be in the you want an item, and I want you to execute. Well, okay, so I don't need to flip it. My bad. I thought that I do. Good. Delete object. Oh, I guess, yeah, we don't need state here because we're working on our items, and map data is what it is. Good. So we can get rid of this. All good, sweet. So state, where else do we have that? I think our updates, look, it's the same thing. So we should change the update into the same. Obviously this isn't a tuple, a unit type, it's just writing this. So an event, and we are not returning anything out of this, we're just changing it, right? And then right here, let ng, the new game is going to be execute state. What state we're executing? Update over a certain event and over an old game, and this is going to give us a new game, and then the render can take a new game and do all sorts of stuff with it. Game loop could probably itself be some sort of state IO thing, and you know, why not just make sure it works. Move avatar, that's yeah, state functions. So monad state, game of avatar, items, enemies, and a tile type. Takes a direction and modifies this. Display character status. This thing is going to take a game and draw it. Excellent. Well, it's going to draw just a character. So it doesn't modify the game, but yes, we did it this way so that we can chain it on. And right now, this is going to be pretty simple, because we want first to move the avatar, right? And then we want to display status. Same here. We want to display status, and then the pickup item. Oh, here we don't need the original game, or here because we are already having it in a state. So pickup item, and let's not be lazy here with this type constraint. It just makes things more complicated. B and D. I don't even use a B type, do I? This is just a, oh yeah, it's just a leftover. Okay, B. So let's make sure we name them the way we did. Equality of I, because we want characters, items to be equal to the items we carry in the game, so that they can end up in each other container. And C are our enemies. And all of that is happening over a tile, right? And then we want MonadState constraint over items, enemies, and oh, it's not that. The correct is a character over item, so we need to specialize that. And then right here, we don't return any value. We could, but that's it. We don't have no game. This is going to require some fixes, but sure. Let's go from the beginning. 175. So we don't handle any of these. So we're just going to write pure quits running set to false, and we're going to use the MonadState operator here. Okay. OG, so avatar position from the original game, and we can do that by I think we can ask, or no, get, yes, get or gets. Yes, get is going to return the whole state, and get is going to take a function to return. But this is a len, it's not a function, so what we need is I think views, if I remember correctly. Monad reader, lens like. No, it was uses. Yes, MonadState, take a lens. That's good. So views, avatar position, and then pick up item at this position. Default is grass coma. Would this be clearer like this? Perhaps this isn't bad. Actually, I think I understand what's the problem. The views also takes a function to modify whatever you return. Yes, so you take no, it's not views, it's uses, right? Right, so that's the first error. I need uses, not views. but it's not even useless, because as you can see, it takes a len and then it takes a function to modify the output value of the len, and we don't need that. We just need the value itself. So we're going to use use, which takes any getter and gives the value out. So, and of course we need to import it. Okay. It's not views avatar in a game. We don't even have a game anymore. Now it's, so debug status, it's gonna be equal to show avatar. Okay. Uses avatar and shows it. And I think it's called I'm set, no? No. Set. I don't remember what is the name of the function that's the alternative of this operator. But I do guess I could just do this for now. I don't find this as readable if I have a function called like set debug status or something. We need uses too. Okay, 194. Yes, we don't have an original game anymore. And where did we use it? OG, right here. So OG from, this is all gonna be, so OP is gonna be use avatar position. Obviously this can be done in a much nicer way, but right now I just want to make it work, and then we can talk about cleaning it up. Avatar, okay, so here we change the avatar, and this is a new avatar object from the old robocom. So we just transfer the avatar object from the original game, and then we can do that like this. Use avatar object, and avatar object, yeah, that's fine. And then new position, it's original position per selection vector, maybe new position because we need to test whether we're failing. The original game, we need map data, MD, and of course you're gonna need this, because do remember that this dot is nothing special, it's just function composition. So yeah, MD map width, use map data width, unexpected to what? Yeah. Okay. Now we have to fix this one. So this is okay. So maybe we're gonna pick up an item, maybe we won't, depending on whether we find it or not. And this is all that we execute. Okay. What we're gonna do is this. Okay, so uses items and then try to find the position, right? And this is gonna be maybe object. And then when is just maybe object. How about this? Case and object, or even better, case, and then if it's nothing, do not modify the state, just return the original value. But if it's an object, and by object I actually mean something from the ground, then let's perform all of these. Okay. We're gonna need map width here. So I didn't do this correctly. It's just mechanically been working on it, and no, that's not what I wanted. So let me do diffs just to remember what was. Find, that's what I missed. We're finding, find. Oh, okay, look, compiles, nice. And we don't need this operator anymore, which is nice. I'm gonna push this down so that it kind of pairs up with its. Oh, look at that. That's very nice. All right. Do we have anything else we need to check? So I'm gonna do this Vim grab. That's gonna give me a list, right? Vim grab. From the start, we're gonna accept only white space and any amount of it. Then some sort of identifier followed by a space and this operator. This should give me all the function type signatures. And do it in the src directory, ignore the depth, grab Haskell files. Open, no match. How come no match? Okay, how about this? Instead of, okay, because it's not just one letter, right? We want multiple letters. But instead of doing this, I'm gonna do something else. We know that identifier cannot contain space, so we're gonna be looking everything and except all. So from the beginning of the line any amount of white space, then look for at least one non-space character, look for a space and then boom. And then we have a list of all type signatures. Yeah, this guy sneaked in, but that's fine. Tile character, state, remove from inventory. Sure. Initial game creation, game loop. Add entry. This is used in a fold, even if it satisfies a similar pattern where it takes something and the return is exactly the same type out. Yeah, I guess that's it. We are at 50 minutes, like right on a clock, so I think that's gonna be it for today. And since I've cleaned up everything I wanted to clean up, next time let's do some gameplay. To give you a very quick, very overall idea that I have, and please feel free to pitch in if you have any better ideas. I'd like to create some sort of a puzzle type roguelike where you collect ingredients from in the world, you use alchemy in certain way to create useful potions or things from these ingredients, and then these potions help you go through obstacles, like giving you ability to breathe underwater or ability to swim in lava or whatever, maybe just being visible against certain types of monsters. I'm not really sure, but the very interesting part for me is to try to develop this alchemy algebra, and sometimes in the future I'd like to actually do a video with very little coding and show you how I try to apply category theory to create such composable systems. That's it. Thank you for again watching, and I'll see you next time.